Hi friends, in our last session we have started with our new chapter control system, in which we have discussed functions, requirements and classification of control system. In today's session we are going to discuss centralized control system. In that, simple centralized control system and pre-selective centralized control system. This is Faizan Kagdi and I welcome you all for lecture series of machine tool design. So let's begin with our first topic. So speed and feed changing by simple centralized control. So as you can see on your screen, there are two views shown. The first view is a side view and second view is a top view of our control system. Now in this system, it represents a cluster of gear, which means we should be clear that we are going to use this control system to actuate the gears. Okay, that is to operate the gearbox. Okay, which means we are going to shift the cluster gears, okay, from one speed to another speed, so that we can say that speed will be controlled by this type of a control system. Now in a side view, when we see this side view from a top side, so it is going to look in this way, which you can see that is a top view. Okay, now let us understand the construction of this system. So this line represents the shaft on which a cluster gear is mounted. So you can see 1 and 2 is written. So 1 and 2 is a representation of a double cluster gear. Okay. This point number 3 represents a gear shifting fork. So this is a gear shifting fork. This 4 and 5 numbering which we have given is a shifting rod. On this shifting rod, there is a recessed block. Recessed block means a block in which there are grooves provided, and in that grooves, ball joint is fitted, which means a ball joint can slide in a recessed block from one position to another position. Now this entire portion is called a lever. Okay, so this 6 number represents a lever, even it's called a joystick. Okay, this 7 number represents a ball joint which is provided in a on a joystick, even it's called a swivel bearing. Okay, now remember, we need to keep this in mind that this is a side view. So when we look this side view from a top side, so how it's gonna look? So it's gonna look in this way. You can see that this is our arrangement of a double cluster gear, which over here you can see in a side view. Okay, now obviously these gears will be in meshing, right? So in meshing with what? So in meshing with the output shaft. So this shaft which you can see, that is a gearing arrangement is provided, it is a output shaft. Okay, now when we look this rod from a top side, that is 4 and 5, so it is going to look in this way from a top side. So you can see a 4 number, that is a rod, shifting rod, and second one is a 5 number shifting rod, which are within the bearings. Okay, bearings are going to provide support to these rods. Okay, on these rods, what is there? So you can see on a side view that there is a recessed block which is provided. So this portion which you can see on a top view with the darkened portion, that is 9 and 10, is a recessed block which is also can be seen in a side view, this portion. Okay, that is 9 and 10. Okay, now since there are two gear shifting faults, that is represented by point number 3 corresponding to the two shifting rods, at a time only one shifting rod will be engaged in a recessed block. Okay, and along with that, by operating a lever, we are going to move either of the two double cluster gears. Okay, so let us understand its working. So as you can see in this figure, we can say that two double cluster sets are operated by a gear shifting forks which are actuated from a shifting rod. So this shifting rod 4 and 5. Now this shifting rod carry a recessed block, as I have told, in which ball tip, that is a ball tip means 8 number. Okay, this ball tip moves in and pushes the rod. Okay, now the joystick can enter at a neutral position either of the recess. Okay, but once the block has been shifted, the joystick cannot enter the other recess unless brought back to the neutral position. So it is very obvious that once a ball joint is engaged in one of the recesses of a corresponding shifting rod and it is shifted for moving the double cluster gear, then it cannot be shifted or it cannot be moved in the another recess of a block until and unless it is brought back to the neutral position. Okay guys, so I hope that you are clear with the speed and fit changing by this simple centralized control. Now let's proceed further to understand the next type, that is a speed and fit changing with a pre-selective centralized control. So as you can see on your screen, there is a one element of this pre-selective control system is shown. So let us understand this first. Now you can see on the bottom side there is a reservoir shown in which oil will be filled. This portion which is shown by hashing lines represents the strainer. So any dust particle or any foreign material which is present cannot enter into the gear. Okay, so this is our gear pump. Okay, so strainer is going to filter, gear pump is going to increase the pressure of a oil and will pass that oil into a direction control valve. Stop valve is provided over here. So stop valve is going to control the flow of a high pressurized oil coming from a gear pump. This portion which you can see is a ball type pressure valve. So we have discussed this ball type pressure valve in our chapter 1. So what is the function of this valve? So we would say that whenever the pressure in this hydraulic line is increased beyond a permissible limit, so it is going to discharge the excessive oil back into a reservoir. So simple, right? So you can see just a circuit type is shown, that is for a ball type pressure valve in which a zigzag line is a representation of a spring and this circle is a representation of a ball. Okay, remember this is a ball type pressure valve. Now direction control valve, we all know the function of a direction control valve. So the two lines from a direction control valve is connected to our hydraulic cylinder. Now within this hydraulic cylinder there are two pistons. On this side there is a one piston, on another side there is another piston. And on this piston rod there is a gear shifting fork. Now you can see this fork is in contact with a double clutch gear. So this is a representation of a double clutch gear and this line is a representation of a shaft. Okay, which we have seen in our previous simple centralized control, right? So again, this arrangement of pre-selective method is used for controlling and changing the speed of a gear box. It is very simple. Now why we need to use a pre-selective system? So let us see that it becomes desirable to cut down the non-productive time, which we know that it includes time required for changing speed and feeds. Now this is possible by providing a pre-selective control system. In this system, changing of speed and feed is carried out during an operation, which means when an operation is going on, we can change and actuate the speed. That is the next successive speed which we need to shift can be done at a time of operation. Okay. Thus, we can say overlapping of a non-productive time and machining time will take place, and this will save our time. Okay. So when an operation is over, speed is rapidly changed by just shifting the lever or by just giving a motion to a lever or pressing a button. Okay. Now let us understand this arrangement which is used for shifting double clutch gear. So as long as the stop valve remains closed, the direction control valve can be manipulated without affecting the position of a piston. So once a piston is in a particular position and the gear shifting fork has shifted the double clutch gear, which means an operation has been started. Right. Now while operating, we know that this piston is not going to move. Why? Because the gear shifting fork will be in engagement position. Right. At that time, we can manipulate a direction control valve in order to obtain a next speed, which means it is a preliminary arrangement for shifting to the next successive spindle speed. Okay, which means when our operation is over, directly we can shift to the next speed without doing an extra work. Okay, so at that time what we are going to do, we are going to close this stop valve, which means further oil will not be transferred into a direction control valve and easily we can prepare for a next position of a spindle speed. Okay, and this will be done when? At a time of ongoing operation. Okay, later when operation is finished, we can say the stop valve will be opened, which results in a redistribution of oil in a high and a low pressure chamber and thus changing the position of a piston. Hence, along with a piston, fork shifts the gear block. So this is how this arrangement of a system is going to operate. So this is one of the part. This is a representation of a two position shifting device. Okay. Now we need to see a next part of our pre-selective control system. So let us proceed further. Now this is a schematic diagram of a three position shifting device. Okay, again we can clearly see that it is a piston cylinder arrangement in which two hydraulic cylinders are placed. Within that cylinders there is a piston, but there is an addition in this diagram. You can see it is shown by hatching lines. Okay, so this is a representation of a plunger. Okay, there is a two plungers placed, plunger 1 and plunger 2. Both the plungers are hollow. Okay, and within this plunger there is a stepped piston. Now what is a stepped piston? So stepped piston is a one which looks as a staircase. Okay, you can clearly see there is a one portion of a stepped piston and there is another portion which is of a broader size. Okay, now how it's gonna operate? So we would say that it is going to use for shifting fork F3 and F4, which must occupy three positions. So F3 and F4 are the fork in a actual hydraulic centralized control system. Okay, which we are going to see in our next successive slide. The stepped piston, which you can see in this diagram, is so designed that if moved in any direction, it pushes one of the plunger. Okay, the piston occupies two extreme positions when oil from a high pressure line is fed into one of the cylinders, and it occupies a middle position when oil is fed simultaneously in both the cylinders, which you can see shown by the arrow. Now, it seems likely that the stability of a piston when it occupies a middle position can be easily disturbed when a slight variation in one of the cylinder takes place due to a change in pressure. Okay. Now, whenever a hydraulic equilibrium is displaced, for example, let's say take an example that on a left side of a cylinder there is an increment in a pressure. Because of that, we can clearly say this stepped piston will slide inside a plunger. Now plunger has its extreme position, okay, but I can say that a stepped piston can slide. So because of this sliding motion of a piston, it is going to push this plunger 2, okay, the second plunger and a piston 2 arrangement. Now as soon as it pushes this, we can say there is also a pressure of a oil on this right side of a cylinder, right? So this oil is going to push a plunger towards the left side, right? That is, it is going to push the plunger towards the left side as well as a stepped piston. Obviously the force at a right end of a piston will be greater and it will restore the piston back to its initial position when a hydraulic equilibrium is displaced. This will be done automatically. Okay, so I hope that you are clear with the three position shifting device. That is, two extreme positions in this we can achieve, as well as a center, that is a middle position, can be achieved by this arrangement. Now let us combine both the arrangements which we have seen for this pre-selective control system in our actual diagram. So you can see this is a schematic diagram of a hydraulic pre-selective control system. Over here you can clearly see F1 and F2 are shown, which means fork 1 and fork 2, over here fork 3 and fork 4. So this is a representation of F1 and F2 for a 2 positions, and this is a representation for a 3 positions of a shifting fork. Now let us understand this. This is a bottom side, you can see there is a reservoir shown. Again there is a strainer and this is our gear pump. Okay, this M1 is a manometer. So this manometer is going to measure the pressure in this hydraulic line. Okay, this will be represented by this manometer. Now this is a speed selector and this is a lever. Okay, so by operating this lever we can actually control the flow of oil inside this cylinders. That is our 2 position and a 3 positions arrangement. Okay, now on a top side you can see there is a V2 line. That is, V2 is a delivery valve which is going to transfer the high pressure oil to the lubricating lines, which means we know that in a machine tool we require to give a oil, that is a lubrication oil, while performing an operation. So this 3 line is a representation of a supply of lubricating oil. Okay, and this will be done through valve V2. Okay, now M2 again is a manometer which is shown, going to measure the pressure of a lubricating oil. Okay, so whatever oil which is passing through this, its pressure can be determined by M2, that is manometer 2. Okay, now whenever there is an excessive pressure in this line, we would say that extra oil can be flow back into a reservoir through this line, which you can see, on which valve V0 is provided. So valve V0 is going to transfer the excessive oil back into the reservoir. Okay, I hope that you are clear with this. So in this high pressure chamber, oil is fed. Now we need to keep this in mind, the values. So oil is fed at a pressure of about 12 kg force per centimeter square. The pressure of a oil is discharged from an outer chamber and it is reduced to about 8 kg force per centimeter square through valve V2, and it is delivered for lubricating purpose. So the oil which is delivered for a lubricating purpose has a pressure of 8 kg force per centimeter square. The oil is discharged into a sump through valve V0 as we have discussed, and it is set at a pressure of 2 kg force per centimeter square. The pressure of a high pressure line is monitored by M1 manometer, which I have discussed, and that of a lubricating line is measured by M2 manometer. Now pressure relays are mounted in a high pressure line and a lubricating circuits. Relay R1 of a high pressure line is connected in an electrical circuitry of a spindle head. If the oil pressure is insufficient, the change of speed fails to complete the electrical circuit and the spindle remains stationary. The working is very simple, that if the pressure is insufficient to operate, that is the oil pressure is insufficient, then a change of a speed will fail to complete the electrical circuit and spindle will not be operated. Clear? Okay. Pressure relay R2 switches on a green bulb if a pressure is sufficient for a lubrication oil. Okay, so we can clearly say that R2 is a indicator. Green and red type bulb will be illuminated. Okay, which means that if a pressure is sufficient, green light will be put on, and if a pressure is not sufficient, red light will be put on, indicating insufficient pressure. So we can clearly say that pre-selective systems are found to be most economical and feasible when employed on a production machine tools required for frequent changing of speed and fits, specifically in capstan and turret length. Okay guys, so in today's session we are keeping up till here. We have discussed today two types of control system: simple centralized control and pre-selective centralized control. In our next session we will discuss selective centralized control and adaptive control system. So till then, stay tuned and thank you all.